from different samples like blood, etc. And we have started with the physiologic biosensor. So how the antibody and the target antigen, once they connected, how the mass changes, that mass changes, how it is reflecting, in the AC voltage, either increasing or decreasing, all those things. So with the help of your physiologic based, devices, we can detect either your the targeted antigen is, connecting with your antibody or not. Okay. So not only piezoelectric biosensor, you can also use some other types of magnetic based things, as well as the conducting polymer based biosensor, etc. So, so one of the biosensor called Magnetorestrictive biosensor, which is nothing but they use the magnetic alternative magnetic field to detect either your antibodies getting, attached to that target or not. Okay. The magnetorestriction or magnetorestrictive means the kind of ferromagnetic property of material which causes due to the changes their shape when it is subjected to the high magnetic field actually. Okay. Say for example, okay, yeah, you assume that this, the platform is magnetorestrictive material, and of course, you have on top of that you have one biosensor chip actually. And yeah, with the help of that, foil, you can develop those, magnetic field. Okay. And I mean, kind of like once the target, the antigen, once it is connected with your antibody, what will happen? That your mass or some sort of, the frequency will change in your, biosensor chip actually. So that again will disturb your, material, the magnetic field actually. So as a result, since you have this platform, magnetorestrictive platform, what will happen? Their shape will change because, once the weight or some sensing was, started, what will happen? The changes in the magnetic field will occur actually. Once the magnetic field changes, of course, that will induce some sort of movement or some shape changes will happen to that magnetic static material. Okay, this is the output, and this is the input, and this is the output. Okay, so as a result, like you will have this kind of like double confirmation, because once the antigen which is connected with an antibody means there will be a changes in the mass. Okay, say for example, even if you have the piezoelectric based biosensor or any other kind of magnetic based property of your biosensor, the alternative current magnetic field will change. Once that field changes again, that changes in the frequency of magnetic field will disturb the this another platform which is like a magnetorestrictive based material, because that shape or some sort of movement will happen. So that again further confirms that the sensing is happening within the samples. Okay. So yeah, this is how the magnetorestrictive biosensor works. Like, so basically, it's a kind of magnetorestrictive microcantilever based device usually works, and we can also use as a remote biosensor platform, and that works well in the liquid as well as in the air. Okay, and the principle of the biosensor is based on the changes in the magnetic resonance frequencies. Okay, with the help of any mechanical load changes. And once the probe antibodies are fixed on the upper biosensor chips, and due to the magnetic restriction or the magnetorestrictive effect, the applications of an alternative current magnetic field using the drive coils induces an acceleration of those cantilever. Okay, or you can say that kind of the movement will happen to the cantilever. Okay, for this cantilever. And that of course will happen only with the changes of mass load, because once the target antigen is connected with that antibody, the mass change will happen, and as a result the field will change, the magnetic resonance frequency, and that again will affect your magnetorestrictive materials. Okay, so as a result, like you're gonna have those double confirmation that your the biosensor is detecting some species. And the oscillation results in an emission of an magnetic flux, and changes in the amplitude and the phase signal of the oscillation lead to a magnetic flux change, and that can be detected using pickup coil. So again, you will have this kind of changes in the frequency, like before binding and after binding. So I mean, by taking that changes in the frequency, you can say how good the sensitivity or the how intense the detection was. Okay. So we can also detect, I mean, using the conductive properties of the polymers, okay, based on the electrochemical devices. Okay. So you have the, I mean, electrode, which is made up of, I mean, conducting polymer. Okay. I mean, sorry, electrode. On top of that, you have that conducting polymer based coatings or the films, etc. And that actually, I mean, that surface actually has, I mean, kind of biomolecule recognition, or you can say like antibody. Okay. So once the target analyte, okay, of your sample gets, I mean, attached or interacted with your biorecognition molecule or the antibody, okay, what will happen again? There will be changes in the, I mean, conductivity or the electrochemical signals. Okay, so that again will be reflected in the any kind of potential stat, I mean, instruments, I mean, electrical characterization. Okay, there will be changes in the voltage or the current, I mean, output. Okay, so that will give you the idea about how much the sensing, or is there any, I mean, I mean, the species was reacted or the detected or not. Okay. So the conductive polymers are widely used as an electrochemical sensor, and the analytical device containing the conductive polymer converts the chemical potential of target analyte into the proportional measurable electrical signals. Okay. And the main goal of modifying a sensing electrode with the conductive polymer are to improve the sensitivity and the selectivity while reducing the effect of the interfering reactions. Okay. And the CP modified electrodes are attached to the bio recognition molecule or kind of like an antibody, okay, and which specifically interact with the target analyte. Okay, I mean, which usually comes from the samples, and once if they reacted, okay, then you'll get changes in the, I mean, output, like a current or the voltage. Okay. So likewise, also you can use, I mean, conducting polymer-based material for biosensor application, because the ultimate, I mean, aim is to use this sensor for a long time, as well as durability, to enhance the durability. So in that case, like if you use polymer-based material, you can have those flexible-based biosensor, and the durability also better as compared to maybe of ceramics and the metal-based one. Okay. So that's all about the biosensor concept. And yeah, from the next class, we will discuss about your this one metal-based material for various advanced engineering applications. So yeah, that's it. If you have any basics doubt on this, we can discuss. So with the help of this material properties, like we have a different types of physiologic material which has different physiologicity. Of course, the magnetic properties as well as the conducting property of soft polymers. So if you want to have better results with even the small quantity of detection, probably we can use I mean, magnetostatic based biosensor to make sure that your results are, accurate as well as the prominent. Okay. And you can also use like a better polymer which conduct, I mean, better actually, because if you see the, I mean, conducting polymers, we have a n number of polymers. So among them, there are few polymers which has excellent, I mean, more conductivity, I mean, properties. So you can choose that, and I mean, once you do that, choose those kind of polymer, even they can detect the small changes of this sensing characteristics. So, so yeah, this is how it works. And if I give you the choices of biosensor, like a piezoelectric one and magnetostrictive based one, and and the conductive polymer-based one. So which one will, which one give you the accurate and more, prominent result? Because you'll have to go out with this magnetorestrictive one, because this will give you the further confirmation, like a dual confirmation. Because one you get from the biochip or the physiologic based one, and then another one you get the confirmation from the magnetorestrictive based material. That's it for the today class. And if you have any doubts or some basic questions, we can discuss. Otherwise, see you tomorrow. Okay, Prakriti, you have sent one email, right?
Hello, sir.
Yeah, you have sent email, right? To
Yes, sir.
clarify.
Yes, yes, sir.
Yeah, I tried my best to give marks, but some of the answers were I could not give marks because some of them were copied from the Google. So anyway, I'll
So,
open
but
your
some
answers.
general answers, like for I think the reason one, the difference between the curated about reason one you asked the last question in my set.
Yeah, yeah.
So, I mean,
Because
I
I
just
did
want to
not.
know like where I could have, yeah, where I could
Yeah,
have scored more, or what you wanted in the answer like that. So I think I sent it via my NITK audio account.
yeah, this is my NIT ID only.
Okay.
It's missing. Why?
I don't know, sir.
I didn't delete.
So I'll check again.
You have multiple ID or what?
Um, I mean, I sent it to your NITK account via my NITK account only, so I'll just check. Should be there.
Anyway, so actually, right after the exam, I have discussed the questions in the class. What is the answer and what exactly I was expecting. You also can refer. Yeah, here.
Did you finish?
Yeah.
Yes, sir.
So you have clarification on two questions: drug release characteristics and resins and cured rubber.
Yes, sir.
So how to release the drug from the chemically loaded one, encapsulated drugs? Tell me.
Sorry, sir.
No, chemically encapsulated drugs into the carrier. How to release it? Tell me.
Sir, I'm not really sure about that. This is something that I had already presented in the biomaterials part for my seminar, so I remembered it from that side.
That's what you can tell
I don't
now.
know exactly. Sorry, sir.
No, that is what. Can you please tell me now?
Uh,
Because see,
how are the chemically
yeah,
released?
because I asked you specifically discuss about the difference. Reassessment difference. I could not see any difference. See, first of all, how drug release. Profile of physically loaded one, that also was not there. You are saying control release, harmful effect. How it is released? First of all, that's fine. But
I mean, do you
I
want like the process or like the differences in now the advantages, disadvantages?
no. The question is briefly discuss about the drug release profile.
Okay.
So, so at least if you tell now, then I'll give you the mark. How the
Uh,
drugs are released from the carrier by physically or if it is stacked chemically.
if it's stacked chemically and if it's stacked physically.
Yeah, you start from, yeah, okay.
So for the physical one, I mean, you you can say it like like a encapsulated one.